Hi, this is Professor Pradyot from Leadib Academy. So we are looking into this IBDP Chemistry HL Paper 1 of May 2019. Okay, we are looking into the video solutions. So what is important part of this video solution that it won't be just purely the solution, but I'll be explaining the underlying concepts. Okay, so that it becomes very interesting and as well as very useful for you. Okay, and we are basically Leadib Academy. We are providing the courses of all the IB subjects like chemistry, physics, maths. Okay, so please do visit our website, okay, leadibacademy.com, where you will find our courses, okay, so that you will get a deeper understanding of all these concepts what we are learning. Okay, so let's begin our story. Okay, so we are looking into the question. Okay, question number 21. So what is being asked? Simple. Which is the correct for the reaction mechanism shown? Okay, so we have been given these three reactions. Okay, 2A giving B plus 2C, B plus C giving D plus E, and C plus D giving E plus. And they are asking overall reaction. So what we should be doing? So let's write it down. 2A. Sorry. Okay. Oops, sorry. Okay, let me rewrite. Okay. So 2A giving B plus 2C, then B plus C giving D plus E, and then C plus D giving E plus F. So for overall reaction, the logic is simple, add all, okay? So what I'll get, 2A plus B plus 2C plus D, and on the right hand side, it would be B plus 2C plus D plus 2E plus F. Can we cancel something? So let's start doing some cancellation. The common things, yes, B is being out. So what does it mean? That means it must be intermediate. 2C gone. Okay, simple. And what we are left with is this. Okay, and D is also gone. So what is left is simple. 2A giving 2E plus F. Okay, very simple. So in this case, we are getting two choices. Okay, or how many choices? Okay, so let's understand how many choices we are getting. So 2A giving 2E plus F. Okay, perfect. Then what else we can think of? Okay, so another thing what we can look into is simple, that rate equation. So what is the concept behind rate equation? So first of all, we have basically getting this 2E plus F and this. These two options are available. So let's try to analyze. So in this case, what is the concept behind rate equation? Simple. So rate is equal to K, rate constant, into whatever are the reactants. Okay, so in this case the reactant is A and a coefficient, okay, that is possible that it can be square. Definitely C and D are not there in this, they are not appearing, so this is out. So it could be square, okay, because this is the order of reaction. We cannot make out by just looking at the stoichiometric equation, but definitely we have to focus only on the slow reaction. That is basically what we call rate determining step. Very important. Okay, so it is basically nothing but rate determining steps. So we need to be very clear on that. Okay, so This is basically nothing but rate determining step. So we pick up the rate equation from there. Okay. So what is the correct option in this case? Simple. The correct option is D. So what we have learned from this, how to determine the overall reaction. So you add whatever are the reactions which are provided, because this probably reaction is taking place in 3 steps. Okay, so this is the multi-step 1, 2, and 3. The first step is the slowest step or slow step, that is going to be RDS. So the entire focus would be only on that. That's the logic for determining the rate. Okay, very, very simple conceptual. Good question. Okay, let's look into this interesting question from chemical equilibrium. Simple. Okay, question number 22. So Kc is given for this reaction. So let's write it down. What is Kc? So 2N2O. Okay, I'm not mentioning the states just for this simplicity, plus O2, and Kc is given, okay, 7.3 into 10 raised to 34. Okay, Kc is very, very high. So that means the forward reaction is very much favorable anyways. Okay, now what they are asking is this, that we need to determine for this reaction. So N2 plus half O2 N2O. You can clearly see now that first of all, in the given reaction, the N2O is the reactant that is on the left hand side, while what we want, N2O, is on the other side. So what clue we have got? That means we have to first reverse this reaction. So let's write it down. So 2N2 plus O2 giving you 2N2. As soon as we reverse, what happens to the Kc? The new Kc will be, I'm just mentioning K-C, it reciprocal. Okay, we get its reciprocal. Simple. Okay, by reversing the reaction, the equilibrium constant Kc gets, okay, basically we get reciprocal. Now we can see that in this target reaction or desired reaction, okay, we need, there's a coefficient of N2 is 1 and oxygen is half, and this. So that means we need to divide by 2. So what we'll do now? Dividing by 2 on both the sides, obviously. So what we'll get? We'll get now the desired reaction. Okay, so this is the desired reaction, but now the new Kc, as soon as we divide, that means there is a power. So 7.3 into 10 raised to 34 raised to half. So what does it mean? It means simple. That means simple that it is nothing but square root. You are aware of this from the indices. So we can very well write like a square root. Okay. Raised to half means square root. So which is the correct option? Straightforward, you can see that the correct option is B. Option B. So what are the learning from this? When we reverse the reversible reaction, the equilibrium constant Kc gets, okay, we get its reciprocal. And if we divide, if we divide or multiply by any number, we get that power, okay, raised to. Simple. Okay, so the correct option is B. Okay, let's look into the question number 23. Okay, obviously it is pertaining to the Gibbs free energy, energetics, okay, delta G. So let's understand what is the concept behind, okay, the positive change, that is the delta G concept. So let's revise quickly. So delta G naught, when it is less than 0, reaction obviously means we are talking of forward reaction is spontaneous, forward spontaneous. I'm writing short. Delta G greater than 0, that means reverse reaction is spontaneous. And when delta G naught is equal to 0, that means there is an equilibrium. Okay, these are the important concepts. Delta G naught is the Gibbs free energy standard conditions. Okay, very, very simple. So if it is a positive change, what should be the answer? Simple. So it means that the reverse reaction is going to be spontaneous. That means what we are going to get? It means that products, okay, so let's write it down, reactants, okay, and going to give you the products. So when we say reverse, okay, that means we are talking of the direction is in this direction. Okay, simple. That means we are going to get more of the reactants. Okay, simple. That means the correct option in this case is very, very straightforward. That we'll be talking about the option A. Okay, the formation of reactants is favorable or favored. Simple. Okay, so Gibbs free energy gives you the direction of the reaction. That is very, very important concept. If it is less than 0, that is a negative one. Okay, then the forward reaction is spontaneous. That means the products are favorable, product formation is favorable. Reverse delta G is positive. That means reverse reaction. That means reactant formation is favorable. 0, that means both. Okay, both means there is an equilibrium. Very, very simple concept. Okay, let's look into this question number 24. Simple one from acids and bases. Which solution is basic at 25 degrees Celsius? Okay, now very important to remember 25 degrees. Okay, so what is the concept? Very, very simple concept that if pH is less than 7, acidic, pH greater than 7, basic, and obviously at 7, neutral. Okay, now what is the pH definition? Potent hydrogen. So what we do, we take negative logarithm of either hydrogen ion concentration, or we can write as hydronium ion concentration. Both are perfectly all right. So we take negative, okay, logarithm to the base 10. Okay, it is not the natural logarithm but to the base 10. Okay, and this is the pH. So let's start looking into it. Option A, we have been given hydrogen ion concentration. Simple. So if we take the minus log to the 10, 1 into 10 raised to minus 3, the answer would be 3. So definitely this is not this one. Okay, less than 7 pH. Okay, so this is the pH for the option A. So that is not correct. What about B? So we have been given OH minus ion concentration, which is 1 into this. So please remember how to calculate. So first Kw is given, so we don't need to worry about that. So what we can do, so calculate H plus ion concentration using 1 into 10 raised to minus 14 divided by 1 into 10 raised to minus 13. So we will get 10 raised to minus 1. So again, using the pH definition, you can easily conclude that pH will be 1. Okay. What about C? Solution of pH 4. Obviously, no question, it is less than 7. So it has to be acidic. Now let's explore for the option D. Hydronium ion concentration is given. We don't need to worry about that. Okay. So let's find out. Minus log of 1 into 10 raised to minus 13. And the answer is 13. Okay. And it is a clear-cut winner. Okay. The pH is greater than 7. That is a basic. Simple. So the correct option is D. Very, very simple. So we need to stick to the definition of pH, okay, and what is mean by acidic and what is mean by basic, okay, depending on the temperature. Okay, that's why it becomes important to understand the definition, okay, and the concept, both. Okay, simple. Okay, let's look into the question number 25. With which do most acids react? Simple properties of acids. Okay, so what are the properties? Sodium hydrogen carbonate, okay, that is NaHCO3 plus acid, okay, it has to give carbon dioxide. This is the property of acids. Hydrogen carbonate, okay, with the acid, okay, they will produce CO2. What about magnesium? Okay, it's a reactive metal. When it reacts with the weak acids, it will produce hydrogen gas. Simple. And what about this calcium sulfate, which is a salt, and when it reacts with the acid, okay, no reaction because this is a salt itself. That means it is basically the product, okay, of acid and base. No reaction. Simple. Okay, it cannot react. So what are the correct options? Okay, 1 and 2 only. Okay, so this is the correct option. Option A. Very, very simple, based on the properties of the acids. Okay, and you people are aware of this. This is like at the school level, earlier grades. Okay, let's look into the next question. That is the question number 26. Okay, it is from the acids and bases. So they are asking us which is a Lewis acid but not a Bronsted-Lowry. So first, let's get our concepts very clear. Just revise quickly. What is Lewis acid? Simple. What is Lewis acid? It is lone pair acceptor as per Lewis acid. And as per the Bronsted and Lowry, okay, what is the acid? Simple. It is a proton donor. Simple. Okay, so what they are saying that it should not be, that means it should not be a proton donor. Okay, but it should be accepting the lone pair. That is what they are asking. So let's look into this. So option A, AlCl3. Okay, what is the uniqueness of this? It is basically how many electrons are there in its now the valence shell. You can clearly see that aluminum is having 3 electrons in its outermost shell, okay, and it is sharing because the sharing the 1 each electron from these 3 chlorines. So total it is having 6 electrons. That means it is not in a position to complete its octet. There is a shortfall. It is an electron deficient. Okay, that means it is going to accept electrons very easily. It is a very good acceptor of electrons. So it is very much Lewis acid. Now let's look into it whether it is a Bronsted and Lowry acid. It is talking about proton. Where is the proton? There is no proton at all. Okay, no proton. So that means it is not BNL acid. Okay, because there is no proton. So definitely this qualifies. So right now we will say yes. What about the option B? Let's recheck whether the other options are not qualifying. So what is this? This is the ethanoic acid. C double bond OH. Okay. Is it a Lewis acid? Yes, it can. Okay. It can accept the lone pair. And what about the BNL acid? Yes, there is a proton. Okay. So there is a very much a proton available for donation. Okay. So it is very much qualifies. So it is not the option. What about HF? Okay. Simple. It is having a proton and it can very well accept. Okay. Accept the lone pair? No. Okay. Because there is a fluorine. Fluorine is having a lot of lone pairs. So it cannot. And what about CCl4? CCl4 is not acid at all. Okay. It is like this. Okay, so there is no acidity. Either it is neither Lewis acid nor a Bronsted-Lowry. So the correct option is A, AlCl3, aluminum trichloride. Okay, which is a Lewis acid but not the BNL acid. Okay, very, very simple. So again, you need to stick to the definitions, okay, of Bronsted and Lowry and Lewis acid, Arrhenius acid, okay, etc. So please do check with our courses. Okay, we have covered all these concepts in detail. Okay, and those courses are available with us as a leadibacademy.com website. So please do visit. Okay, you will find it very interesting and you will get a deeper understanding. Okay, let's look into this question number 27. Very interesting, from acids and base. So which has the strongest conjugate base? So let's understand, okay, just recall the definition, what do you mean by conjugate base? So in short, I'll write it in the form of formula: acid minus proton, okay, is equal to conjugate base. Okay. And another concept which you need to remember, that strong acid will always have, okay, weaker or weak conjugate base, and weak acid will have strong conjugate base. Simple concept. Okay, so what we need to find out is, in short, simple, we need to find out which is the weakest acid among all this. So what concept we can understand? How to decide whether which is a strong and which is a weak acid? Simple. There is a very, very simple, powerful tool that is called Ka, dissociation constant of acids. Okay. So higher the dissociation constant, stronger is the acid. So we need to find out, in this case, weak acid. That means the lowest K. And which option is there? The lowest amongst this, all these four, this one, because it is only 6.2 into 10 raised to minus 10. Okay, simple. HCl. Simple. So that means this is the correct option, option C. Okay, so what is the important concept? Stronger the acid, weaker is going to be the conjugate base. Weaker the acid, going to be the stronger conjugate base. And what is conjugate base? You remove the proton and whatever is left over from the acid, that is a conjugate base. Okay, very, very simple concept. Okay, and we have explained this in our courses. Okay, so please do visit our website and do check. Very, very simple. Okay, let's look into the question number 28. Okay, it is from the redox. Simple. Which product will be obtained, okay, at the anode, that is a positive electrode, when molten NaCl is electrolyzed? Okay, now the key word here is the molten. Okay, let me underline molten NaCl, because there is another possibility that it can be a aqueous one. Then the things change. Okay, molten NaCl, very, very simple. Okay, so it is going to be like this, that NaCl, I'll make it like this, 2Na plus plus 2Cl minus. Okay, that is how we can think of. And so then this one, 2Cl minus, okay, at the anode it will release like this, 2 electron, this is going to be at the anode, and then 2 Cl atoms will combine to give you Cl2, okay, in the gaseous form. So always remember, at the anode oxidation takes place. So this is nothing but the oxidation, okay, of Cl minus ion, okay, and always remember oxidation at anode, whether it is an electrolytic cell or the voltaic cell. Very, very important. Okay, oxidation always takes place at anode, or we can think like exactly reverse. The electrode at which oxidation takes place is anode. Okay, and what is oxidation? That means losing the electrons. Okay, loss of electrons. Very, very simple. Okay, so let's see. So which option do we think is it correct? Okay, so we can clearly see that Cl2 gas, simple. Okay. Option C, straightforward. But please be careful that in this case, please be careful that we are talking about molten NaCl. Otherwise, it can be a different. Okay, so you need to be careful that in what condition we are electrolyzing. Okay, okay, it's very, very simple one. Okay, let's look into the next question. Question number 29. Where does oxidation occur in a voltaic cell? Okay, now very, very straightforward. As I told you, oxidation means only anode. Okay, that should be crystal clear, irrespective whether it is a voltaic cell or electrolytic cell. Okay, straightforward. And please do remember that in case of voltaic cell, anode is negative. So voltaic cell, oxidation, irrespective whether it is a voltaic or electrolytic, it will be always at anode. But in case of voltaic cell, anode is negative. Okay, it is a negative terminal. That's all that you need to remember. While in case of electrolytic, the anode terminal will be positive. But please do remember, irrespective, oxidation has to take place, okay, at anode. Okay, so very, very simple concept. So which is the correct one? Negative electrode, okay, and anode. Very, very simple. Option B. Straightforward. Okay, extremely simple concept. And oxidation means loss of electron. So always at anode there is a loss of electrons. Okay, okay, let's look into the question number 30. Okay, again from the redox. Which factors affect the amount of product formed at the cathode during electrolysis of molten salts? The factors given: current, time, and charge on the cation. Let's recap Faraday's law of electrolysis. So what it says, that the amount, okay, amount which is getting formed or material which is getting deposited, okay, it is directly proportional. So let me say amount, okay, or I'll say, to be very precise, product form, okay, it is basically depends on two, okay, charge flown, okay, in cathode, and second, okay, the charge on cations. Okay, so let's understand what I mean by charge flown. Okay, so it is basically can be shown as capital Q, and charge by definition it is I multiplied by T, that is current multiplied by time. Okay, because by definition I is equal to charge upon time, rate of flow of charge, so that you are aware of. So definitely current and time, these two factors. What about the charge on cation? Obviously yes. For example, let's say we want to put this, okay, we want to deposit Na plus. So how many electrons will require? Will require only one electron, okay, to make it Na. But let's say there is an aluminum, that is a 3 plus. So obviously we'll require 3 electrons, okay, to make it aluminum. So definitely the charge of cation, or for example Cu2 plus, so will require 2 electrons. So definitely the charge on cation is playing a role, that how many electrons or how many moles of electrons are required to get reduced, because this is a reduction at cathode. So definitely even the charge on cation is playing a role. And so this is basically as per the Faraday's law. Okay, very, very conceptual, but very simple concept. Okay, hope this is clear. So it means that it depends on all three factors, 1, 2, and 3. So the correct option is D. Very, very simple. Okay, so please understand this, and we are again and again I'm repeating that we have explained all these concepts, and besides that the further deeper understanding, okay, of the concepts, okay, we have explained this and we have covered it in our courses. So please do visit our website leadibacademy.com, where you will find the courses. Do subscribe.